Hi, I'm John Honeycutt. Today we'll go through probability and with and without replacement. Now, probability is similar to statistics, but not exactly. Probability is somewhat like predicting or anticipating what might happen, whereas statistics is reviewing the past and describing it. Now, that's not exactly the difference, but it's close enough to get a little bit of a feel. So in your textbook, the first half talks about statistics and the second half is on probability. And we're going to go through with and without replacement. And we'll get there. It's going to take a little bit, to be honest, but we will get there and then compare it without replacement to with replacement. And most of the time will be spent on without. So these characters, to complicate things just a little bit, these actors will go to 4 different locations. All of them will go to each location, and then they'll go to the second, then to the third, then to the fourth. But initially, what we'll look at is the probabilities that the mix or the sequence of first, second, third, fourth place, all the different combinations that exist for these 4 people at one location. So there's lots of different varieties or variations, and we're going to come up with how many first, second, third, fourth, that kind of thing. Now you'll notice I'll keep the 1, 2, 3, 4 at the top constant. It's just to remind us that there's 4 places, first, second, third, fourth, and then at the bottom I'm going to keep the word without, because this is without replacement, and you'll see what I mean in just the first 2 scenarios. So let's say our first actor gets second place and our next actor gets fourth place. So that leaves us with first and third, and so we've got first and third. So that's one possible way that these 4 people could come in first, second, third, fourth place. Now let's look at another way. Let's go ahead and put 2 and 4 back up there just like before. And what are the possibilities for first and third? Well, our third actor might get third in this place, and that leaves first place for our final actor. Let's put 2 and 4 up again one more time for our first and second actor, second place and fourth place. And let's try a 3 here like we've had before. And if it's a 3, well, that doesn't work because that row, that new row I just added, is identical to the row above it. So that's not a new combination. How about if we put a 1 in that third player's spot? Well, if we do that, it only leaves us with a 3. So that's not unique either. That's identical to the first sequence that we did. So whenever there's only 2 options in this case. If you have a 2 and a 4 in the first actor's and second actor's place, then there is no other option left. It's just 2 options. So let's try a different number in first and second place. And so we're going 3, 4, 2, 1. And that's legal. That's a brand new combination. And if we select 3 and 4 again as our first and second actor, well, we could put in a 1 and a 2 at the end, or a 2 and a 1 at the end, but there's no other options left that are unique if we use 3 and 4 twice. So we can't use the 3 and 4 again. How about 1 and 4? Yeah, we can do that, and each one of these new rows is unique. So what we have are 3 different combinations, but our second actor came in fourth place in all of these instances. Probably a little bit sad. So let's create a new instance, and in this case, someone else is going to come in fourth place each time. And that leaves us, so this first person is going to be sad, got fourth place in all the possibilities. And if we fill out the rest of this matrix, you don't need to take time to look at it, but these are the combinations of without replacement for these scenarios. Now, it turns out that that's only half of the options. I'm not going to take you through the remaining options, but there's twice as many. So if you counted all these up, it's going to give you, I think it's 24 variations. So now it may be only one time that they play a game, but there's 24 variations of who comes in first, second, third, fourth. So 24 total variations. Now, this is at one location. This kind of looks like a spooky place. I'm not really sure. So they all are competing at this one location. There's 24 possible combinations of who comes in first, second, third, and fourth. Well, if they move to a brand new location, it's the exact same. There's 24 different combinations. They just start over at the new location. So someone comes in first, second, third, and fourth, and it's just 24 possibilities. And if they go to all four locations, there are 24 variations or combinations at each one of those locations. So if you add that up in this scenario, it's 24 plus 24 plus 24 plus 24. It's a total of 96. Now in the middle, I do want you to read this. It's 96 total possible combinations without replacement, where each of the four locations has 24 variations. So the extra locations complicate this a little bit. The main thing that I want you to get is that there's 24 possible combinations at one location. So if we had two locations, it would be 48 total, that kind of thing. And the way that you calculate this, rather than manually on a spreadsheet or something, it's 4 factorial. And in this case, it's 4 factorial 4 times. And so that's why it's a little confusing, the number 4 used in more than one way. But each location has 4 different players, and all the players would come in first, second, third, or fourth. So the various combinations that are possible at each location is 4 factorial. Now, what is 4 factorial? That's 4 times 3 times 2 times 1. And it's a 4 with an exclamation point after it. So you can look at your Algebra 1 book to find factorials. Now, here's without replacement. So let's look at the difference here. Without replacement, it's a total of 96 in this scenario. With replacement, the total is 1,024. That's because the varieties, all the various combinations with replacement, is 256 at each location. So you add those up and it's 1,024. Now the way to calculate with replacement is 4 to the power of 4. So that's the total combinations, and that's 1,024 with replacement. Each of the 4 locations has 256 variations. So it's 4 to the power of 4 added to each other 4 times. So without replacement, first, second, third, and fourth, we have 4 factorial, and that's the number of varieties. With replacement, it's 4 to the power of 4, and that's because it doesn't matter what the first player gets if they beat the clock or don't beat the clock or whatever the competition is. More than one person can get first place. More than one person can get second, or everybody could get first, or everybody could get second. So each player's score is independent of the other scores. So if somebody gets first is still available for everybody. And the way that you calculate it is 4 times 3 times 2 times 1 without replacement, and 4 times 4 times 4 with replacement. And so let's look at just some quick samples of with replacement. So here we see that everybody got 1, whatever that stands for, first place or beating the clock really well. Don't know, maybe throwing 10 baskets and making them all. And then on the second one, there's still 2 people that get a 1 rating and 2 that get a 3, because they're all independent. They're independent variables. And here we kind of switch things around, 1 1 3 1, and then 3 1 3 2. So you'll notice that it's possible for the numbers to repeat for each within the team. And here we've got kind of the 1 2 3 4, and that's what we were looking at kind of in the without replacement, where everyone has a unique number. So that's the end of this. You may have questions, and feel free to send me an email or talk to me in class. And let's also thank our kind characters. And with that, I'll bid you good day.